Now I will try to solve all the miscellaneous problem of this playlist. We have done till now 34 questions, so let's just quickly try to do these questions also. After this video, all these miscellaneous problems will also be completed. So our first question is next permutation question. According to this question, what we have to do is we will be given an array, let's say 1 2 3. What we have to return is we have to return the next permutation that comes after 1 2 3. I hope you know what is permutation. Here are the some examples that are given to us, that for an array 1 2 3, the all the permutations are these six. Basically it are the permutation is the different combinations that can occur using the same digits that are given in our array to different positions. Okay. And what next permutation means is the permutation that comes just after the given permutation or the input permutation. Let me just try to explain this slightly here. Let's suppose if our given array is this. As you know, the total number of permutation for the given length n is total permutation for a given length n is n factorial. So for this example it will be n, here is 3, so it will be 3 factorial, which will be 6. So there are only 6 possible ways to arrange these values in different order to get all the permutation. Those 6 are 1 2 3, then 1 3 2, then 2 1 3, then 2 3 1, then 3 1 2, then 3 2 1. Here our input can be any number, any array or any sequence from here. What we have to do is we have to return the next permutation. Say our input is this 1 2 3, then we have to return this thing 1 3 2, the just next permutation to our given input permutation. Let's suppose if this was the input given to us, then we have to return just next permutation of this. And here there are some key observation that you can make. First one is that these permutations are sorted in lexicographical order. What does that mean? If you only see the values of this, it is quite clear that they are in the ascending order, that this one will be smaller than the next one, then this, then this, then this, then this. Basically 1 2 3 is smaller than 1 3 2, then 1 3 2 is smaller than 2 1 3. So they are in a ascending order. So what that means is that the first element here will always be the smallest permutation, and the last element here will be the largest permutation. That's how the concepts of next permutation comes, because if we have something, we can only find the next of that if there are some kind of order, and here there is some kind of order that is going on. You can also think of this as an English dictionary numbers, how that are arranged. You can consider 1 as A, then 2 as B, then 3 as C. Then you know how these are arranged, that this is the smallest because this will be at the first page of the dictionary, then this will be the second element that will occur because this is greater than this. I hope you know this thing. Okay, so this is the first observation, that how the order is coming into this role and how we are defining the next permutation. Now the properties of next permutation are these. First one, first one, it will be greater than input array or input permutation. Let's suppose if we are trying to find the next permutation of this 213, then the next permutation of this we know is this thing 231, and this, due to the ascending order arrangement, it will be greater than the input array. Basically it will be greater than the previous array. You can clearly see that it is greater than the previous because it is next permutation, so it has to be greater than the previous one. This is quite trivial case I am explaining here. Now the second, this is also a trivial case but a slightly more advanced trivial case which will form our intuition of the algorithm. This property, this realization is that our next permutation will be smallest permutation that is greater than input array. In fact, this is the more advanced case or more advanced observation that you can make. This is the main crux of this solution. If you understand this thing, then all the question is already done. The next permutation, the property which satisfies next permutation is that it is smallest permutation that is greater than the input array or the previous permutation that is given to us. For example, let's suppose we are trying to find the next permutation of this. We are trying to find the next permutation of this. We are trying to find the next permutation of 2, 3 and 1. So can 1, 2, 3 be the next permutation after this? No. Why? Because 1, 2, 3 is not greater than 2, 3, 1. And according to this property or slash realization, we know that the smallest permutation that is greater than the input array, and this is failing that it is not greater than the input array because 1, 2, 3 is smaller. So how can it be occur in the next thing? Okay, so this is one thing. Now can this be the case? 3, 2, 1. Okay, so this is greater than our previous one. This is greater than our previous one, but is it the smallest greater than our input array? Can we do something better? See, there is also 3, 1, 2. This number right here is greater than 2, 3, 1. So this satisfies our greater than input array condition, and this number here is also smaller than this 3, 2, 1. So this number here 3, 2, 1 cannot be the next permutation because it fails the smallest permutation that is greater than input array, because that is only this permutation here. Okay, so for this example, can this be our next permutation of 2, 3, 1? Absolutely not, because again it is smaller than the input array. That can never be the case because it has to be greater than the input array, because we are trying to find the next smallest greater. Next smallest greater. Next smallest greater, you can think of it like a greatest integer function, I believe, if I'm not wrong, or something like that. I hope you know how I am relating it to that concepts, if you know. Okay, but this line is the definition of the next permutation. This is the main definition, that we are trying to find the permutation that is smallest but greater than the input array. So it has to be greater than the input array, but it has to be the smallest of those. Okay, let's say if this is given to us, then what will be the next permutation of this? Let's think of this. Can this be the next permutation? No, because it is smaller than the previous, so it can't be that case. What we can do is we can do this thing. This will satisfy all the cases. Basically there are only two cases, that it is greater than the previous our input permutation, and it is also the best, the smallest greater permutation. Any other rearrangement, let's say this, will satisfy that it is greater than the input array, but it will not be smallest greatest one. I hope now it is completely clear how we are approaching this question and what is next permutation actually means. Now, okay, so in order to calculate the next permutation, I am just copying this example only. It is 1 3 1 4 and 1 3 4 1. Okay, let's just, for a practice only, let's just try to find the next permutation of this. The next permutation of this will be something like 1 3 1 4. No, it can't be that case, so we can't do that. 1 3 4 1, we can't do that because it is already there. It will be 1 4 1 3. This will be the, this is greater than the previous one, this is greater than the previous one, and it is the smallest possible greatest than the previous one. You can't find a better closer to this one. Okay, now in order to find the next permutation, what we have to do is, can you see that in order to find the next permutation of this, we are just sorting this here, we are sorting these elements here. Okay, this is not quite clear right now. So what we have to do is we have to find a break point. We have to find a number that is causing the problem that we have to replace. There is some kind of replacing going on here. See, only focus on this number right here. This number right here. Can you see that this number is getting replaced to this 4, right? And let's say there is some kind of a swapping going on here, then we are just sorting this here. In all the cases when we are trying to find the next permutation, it will be the smallest one, so there will be some kind of a sorting going on there, the internal sorting will be there. But let's just first focus on this breaking index. But how to find this break index, that what is the number that is causing the problem that we have to replace. Here it is this 3 that is causing the problem, and here it is this 1 that was causing the problem, because here if you see, we keep this same, this same, this same, this same, we replace this 1 to 4. And similarly for the second input, this is same, but we replace this with this. So there is some kind of a breakpoint going on. And how to find that breakpoint? You can clearly see that if these two are same, then we continue. If these two are also same, we continue. But as soon as there is some kind of a change occur, here there is a change that is occurring, we have to find this change. We have to find this number that will be our candidate to break our array into two parts. The same part, the replacing number, and the remaining array. Now to find this number, what we can do is, we can do something like, if nums of I is less than nums of I plus 1, we will do break index is equal to I. That's all. We have to do this only. That if nums of I is less than nums of I plus 1, break index will be I. Because if we do this, then let's just try to dry run once. Let's just dry run this one. As you know, our break index should be here. After this for loop, our break index should be here. This is our breaking point. Because this will be the number that is causing the issue. This will be replaced to this. Now this for loop will run that if nums of 0 is less than nums of I plus 1, that is 1, it is true. So what we will do is we will update break index to I, that will be break index will be 0 at start. Then again the for loop will run is break index is nums of I is less than nums of I plus 1. Here the issue is occurring, so we have found our breakpoint. Here it will be I plus 1, or similarly, or in simple terms, we can find this ith position here and we can call this also as our breakpoint. Because here nums of 0 will be less than nums of I plus 1, nums of 1. Okay, we will go to the next index. Here the breaking will occur that nums of I, that is nums of 1, is not greater than nums of I plus 1. That is 1. So this b underscore I will not work here. And we will go to the next step. And what will be the next step? The next step will be to go and update our I. I will be 2 in the next step. Then what will happen is nums of 2 is nums of 3 less than that. Let's check. This will be I at 2, and this will be when I is at 3. And yes, it is satisfying this problem that 1 is less than our 3. So this property is satisfied here. Then our breaking index will again update, and this time it will update to 2. And now after the for loop, because now all the elements are processed, we have found our breaking index. We have found our breaking index. As you know, I have already explained you that this will be the breaking index. This 4 has to be replaced with this one. And we are getting breaking index is equal to 2. If you see the indexing of this, we have correctly gone to the next problematic number that is causing the issue, that has to be replaced with some other number. Okay. So let's just quickly write the code to find the breaking index, the problematic critical point that we need to replace. Let's make int n is equal to nums dot length, then int breaking index will be, let's call it -1. If we are unable to find any breaking index, then we have found an edge case that we will try to solve differently. Now let's run our for loop for int I is equal to 0 to I less than n minus 1, because we will go and check is nums of I is less than nums of I plus 1. Due to that I plus 1, we will run our loop to n minus 1, not till n, because when we reach I less than n, basically n minus 1, then if we try to do I plus 1, it will lead to out of bound index error. If nums of I is less than nums of I plus 1, we will update our breaking index. The breaking index will be simply our I. Okay. No. Now let's just try to print this and see is our algorithm correctly identifying the breaking index point or not. Let's call the index also, and let's call the number also that we have to replace. At last we have to return the null only because we have to update the nums array only in this question. Okay, so there is one edge cases as I have explained you that what will happen if we are unable to find a breaking index. That will only occur in one case when the given array is already sorted in the descending order. Because if this is the nums that is given to us, what will be the next permutation of this? The next permutation of it cannot be a greater element than this, because no matter what arrangement you do, you can't find the greater element than this. So in order to handle this, what they are doing is they are just printing the first element again, because in a dictionary also, if we write a b c d and to till z, what occurs after z in theory is again a. I know this sounds ridiculous, but this is how they are asking, because here you can clearly see that if the given element is already a largest element that can occur, then the next permutation of that is again the starting element. You can again think of it as when you try to do like this. Let's suppose if there is a machine which counts from -2 till our 3. If we reach 3 and we try to add 1 there, we somehow reaches to the last element, the smallest element, because the counter resets. One famous example of that will be when the calendar breaks, that when 199 was there, and when on the New Year Eve all the calendars updated, this was not what they were showing. They were showing this thing, the smallest element that was given in the range that was defined for the calendar. I hope this is now completely clear, because this is the out of the question things that I am saying. Generally, if you see that this is the last element and they are trying to find the next element of this last, then we are just trying to return the smallest element that was there. So what we can do is we can do like, if b underscore I is equal -1, then we know this is the edge case that we are trying to looking for, that the array, the permutation is already sorted in descending order. Now what we have to do is we have to sort them in ascending order, because let's suppose 3 to 1 was our array, and the next permutation of that will be 1 to 3. That is just the sorting of those array. So let's just do arrays dot sort nums, and we will return here. Okay, so for this case now it is fine. For the edge cases it is fine that if the input array that is given to us is already the last element, the last permutation that is possible, then the next permutation of that will be the first permutation, that is the smallest possible permutation. This. Now let's just see that is our breaking index calculation and the breaking index value is correctly being calculated or not. If you remember correctly that if our nums is 1 2 3, then the next permutation of this 1 2 3 will be 1 3 2, 1 3 2. So the changing or the breaking value was this, and we are correctly calculating that because this is the breaking index 0 1, which is correct, and the breaking value is 2, that is causing the issue that we have to change. Okay, so for this test case it is passing. Let's just see for this also. For this one, if you remember, uh, if you try to calculate the next permutation of this, then that will be 1 5 1. So the problematic index is this. Again, it is at the 1th index, so 0 1th index, and the value of nums of 1 is 1. So both of things are getting correctly calculated. So we have calculated a breaking point or a breaking index. Now we just need to try to find the next permutation of that. Okay, so let me just try to explain it here, what is done. And okay, so let me just try to make a bigger example. Okay, so this is fine. If you remember correctly, the next permutation of this will be this 1 3 2, and we have correctly found the breaking point, that is this number. If you see what we are doing is quite simple, that we are not touching the left part. This left part will remain the same. Then what we are doing is we are replacing this 2, this is the problematic index, to the element which is on the right side of it, that is greater than this. That will be 3. So we will swap these two and we will get our answer. Let me just try to use a different or a bigger example in order to fully understand this problem. 2 1 5 4. So for this, what will be the next permutation of this? It will be 2 will remain as it is, 5 will become 4, and this will be the next permutation of this. You can try other combination also. Remember the condition to satisfy the smallest permutation, that is greater than input array. Smallest permutation that is greater than input array. So this will be the only case, that is smallest permutation, but that is greater than the previous array. What will be the breaking point in this case? This is the breaking point. Now see, we are not touching the left part. The left part is remaining as it is, and we are replacing this value, the breaking value, with the same property, that is this property, that we will replace slash swap our problematic value with a value that is greater than our problematic value. because we are trying to find the next permutation, so it has to be greater than the previous one. So if we are trying to replace one element from here, to replace the element that should take the place of this has to be greater than this. Let's suppose if we replace this with 0, then our next one 2015 will become smaller than the previous. We can't afford that. So that's why this condition is coming, that the value that we will choose should be greater than our value. Okay, and it should be greatest element, smallest greatest value that we will choose. This is nothing but the same property of the next permutation, but in the case of value here. What that state in simple terms is that we know we have to replace this one. We can't replace this one with, let's suppose if there was some 0 here, we can't replace that with 0, because if we try to replace that with the 0, it will become something like this, 2054541 or something like that. Then it will be smaller than our previous one. That can never be the case, because next permutation has to be greater than the previous one. And the second case is that the element which we are choosing, that is greater than the value, should be the smallest greatest one. See, the greater element on the right side are this and this. We will choose this 4 only. We will not choose the 5, because if we choose the 5 to replace, then our permutation will look something like this, 2514, and this is greater than the previous one, but it is not the smallest greatest one. The smallest greatest one is this one, and that can only be possible if we choose 4 as our replacing value, because it is greater than the 1, and also it is the smallest greatest element that is out there. Out of 5 and 4, the 4 is the smaller one, which is greater than 1. So we will replace our 1 with 4. If we replace our 4 with 1, what will our array look like? It will look like something like this, 2 4 5 1. Now the last step, only the last step that is remaining is, we will sort this. We will sort the right side, because this is the border index, boundary index. We have calculated it already, so we can swap these two also. And now what we will do is, we will sort the right side of this to get 2415, because we are trying to find the smallest next permutation, that is the closest to the input permutation that is given to us, and it has to be greater than that. I hope now all the steps are clear, that at first we will replace and swap our problematic value with the value that is greater than our value, but the smallest greatest value we will take. After swapping that, we will, after swapping, what we will do is, we will make the bucket of, let's say, b underscore I plus 1 till our n minus 1, and we will sort this array. We will sort the remaining array. So let's just quickly write the code for this. Firstly, I will try to find the value that we will replace our problematic value with. Let's just store it somewhere, that our int problematic value is nums of border of index. This is the value which we will swap our element with, our candidate with. Now we will run a for loop in the right side of the things. We will run our for loop in the right side of the border index. We will run the for loop here to find the replacing or the swapping candidate. We will run our for loop like this, for int I is equal to border index plus 1, signifying that we will search from right side to I less than our n till the size of the array. We will do I plus plus. Now what we will do is, we will check that if our nums of I is greater than our problematic value, and we will try to find the smallest such that, so we will write a mat.min function to find that. Let's make a integer replacing value. Let's initialize with the maximum value possible, so that whenever the min value function will call, it is guaranteed that it will return an answer. Our repeated value will be math.min of, okay, let's just try to find the index first. We will find the index first. Okay, int repeating value index will be, let's call the replacing index will be, at start it is 0. We are trying to find the index of the 4. Basically we are trying to find what is the index for which we have to replace our border index value with. So it will be, okay, we need that also. This replacing index will store the index of that, and the value will store the value. Replacing value, nums of I, and our index will be I. Let's just print these to check are we getting the correct answers or not. So for this case the repeating value is 3, that is coming out to be, that is correct, because if you know that the next permutation of this nums is 1 3 2, so what we are ultimately doing is we are replacing the 2 with the 3, so our replacing value is 3. That is correct for this case. Now for this case it is also working correctly, that if you remember the next permutation of this is 1 5 1 1 5 1. So what we are doing is we are swapping this 1 with the 5, so our swapping value is 5, the replacing value is 5. Here we are printing the replacing value only, so it is correct. So now let's just replace that. To replace, if you know, we need a temporary variable. Nums of border index will be replaced to nums of repeated value index. index, and nums of repeated value index will take the border index value that is stored in temp variable. This is swapping which we are doing. This swap I am doing, that the border index is storing the 1 and the replacing index is storing this 4, and I am just replacing this 1 with the 4. After that our array will become something like 2 4 5 1. Now what we have to do is we have to just reverse the right part, the border index plus 1 till our nth part. We just have to sort them. What we have to do is arrays dot sort our nums. Starting index will be border index plus 1. What will be the ending index? Ending index will be n, I believe. Yep, so all the test cases passed and the solution I believe is quite clear to you guys. We can do something better because here we are not using an extra space complexity. We are solving in the constant space only because we have not defined a extra array or a array list or a hash map. So we are solving in the constant extra memory, but we are using a sorting algorithm, arrays.sort. So it is coming out to be time complexity of order of n log n. We can do something better because if you observe the last critical part, it is just for the optimization purpose, and it is the final nail in the coffin for this question. It is the last observation that whenever we are doing arrays.sort, whether it be here or in the subarray of here, let's suppose if we are doing if we got a b is equal minus 1, this case I am talking about, we are doing the sorting algorithm because there is no such next element that is greater to this 3 to 1. So ultimately what we do is we sort this 3 to 1 and just return this 1 2 3, which is taking a time complexity of n log n. But this is already sorted in descending order. What we can do is we can write a reverse function. That will reverse the array. We will write a reverse function that will reverse the array, and we will get our desired answer. And as you know, the reverse function, the time complexity of reversing is order of n only. Because how to reverse an array? To reverse an array, what we do is we define a L pointer to 0 and R pointer to n minus 1, and we just swap L with R, and we do L plus plus and R minus minus till our L is less than R. So it is just a single while loop from I is equal to 0 to our n. So the time complexity of reverse will be order of n. That will be better than sorting the array. This reverse works here because whenever we are trying to sort, we are just reversing the descending order thing. If the array was something like 2 3 1, then that will not happen, because then if we try to reverse, that does not mean reverse is equal to sort. The reverse is equal sort only in one case, when we are given a descending order already, and that is the case here. Now you will say that we are using a arrays.sort here also. So for this case, everyone understood that this is the edge case and 3 to 1 is already in the descending order. So if we just reverse the descending order, we will get the ascending order. So what is happening in this case? In this case also, in the sub problem, what is happening? We are just sorting the descending order only, but the sub descending order. See, here when we are trying to sort these two, when we are trying to sort these two, clearly one observation is that they are already in descending order. So if we reverse this phi 1, then also we will get our answer, that is sorted answer. This is the key observation which is very hard to find in this question, but I hope I have explained you everything. Let me just write the reverse function so that we can write the order of n time complexity code also. Public void reverse, and to reverse we will take our integer array nums that we have to reverse. In place we will take a starting index and we will take a ending index, basically a left and a right. I have already explained you how a reversing will occur. Reversing algorithm is like this only, that we will start from L is equal to 0 to n minus 1. We will do L plus plus and R minus 1, and we will just swap L with the R. That what we will do is, while S is less than E, we will swap. So int T is equal to nums of start, then nums of start will be nums of E, and nums of E will be equal to our temporary variable. This is just a simple swapping which I have written. Then we will update our pointers. S will move to the right side and right will move to the left side. So this is the reverse function which I have written, and we will replace our reverse function here, because here the sorting is occurring and here the sorting of the whole array is occurring. If you see, when 3 to 1 was the case, then the starting will be 0 and the ending will be n minus 1. So for this case, our base case or our edge case, the reversing is happening for the whole array. So we will reverse the whole array. The starting index will be 0 and the ending index will be n minus 1. Okay. Now for this case I have already explained. That's how writing a deep dry running and explaining the whole steps lead to, we have to sort our array from border index I plus 1 to n. So we will reverse our array from border index I plus 1 to n minus 1. So instead of this sort, I will just write a reverse function. Reverse of nums of B to border index plus 1 will be our starting index, and our ending index will be nums of length n minus 1. Earlier for the arrays dot sort function, we were using n here only because for the sorting part this n is exclusive. This is just the unusual indexing of the inbuilt function of arrays dot sort. So see, all the test cases are passing for this case also. Okay, so there is some issue occurring. Maybe I need to do till n only. Okay, so one test case is failing, that for 2 3 3 3 1. Okay, for 2 3 1 3 3, our next permutation of this will be this thing, but we are returning the wrong element here. Maybe for this we have to do while s less than equal to n, but I don't think that was causing the issue. I know the issue is occurring because of the duplicate values, because of this duplicate 3. So let me just try to do the comparison for the duplicates also, like here. Because whenever the issue is caused by the duplicates of the value, the issue is generally that in our if condition, whenever we are using the less than equal to case, we try to use the strictly less than case, and if we have used the strictly less than case, then we try to use the less than equal to the symbol there. I hope now all the test cases pass. Yep, so all the test cases passed. The only issue was due to the duplicate value. Then when this nums of I becomes equal to the repeated value, that both of them are exactly same, that the 3 is getting replaced with the 3 only. Earlier we were skipping that due to this less than symbol, but now we will also take that into account. Okay, so all the test cases pass. This question was quite a decent one because it teaches us so many different concepts about permutations and how to break the permutation into the next permutation. Actually, to generate all the permutation is simpler than the getting the next permutation code. So this is quite a good question on its own. Now, as the first question is already done, let's just quickly try to solve all the medium question of this miscellaneous first. Let's just try to solve this maximum subarray question. For this question, we will be given an array nums. We have to find a subarray with the largest sum possible and return its sum. So we need to return the maximum sum possible in the continuous subarray for the array given to us. Whenever the maximum sum will occur, we have to return that. Okay. So for this question, there is one algorithm known as Cadence algorithm, if I am not wrong. This is the direct application of that algorithm only. If I am not, if I remember the name of the algorithm correctly, it's known as Cadence algorithm, if I'm not wrong. Yes, so the Cadence algorithm is the direct application of this. This question is the direct application of that. So let me just explain you how that algorithm returns the maximum possible subarray sum, and that too in the order of linear time complexity, that too in order of n time complexity. So that is the best optimal solution we can get, and in the worst case also the solution will remain in the linear time complexity kind of setting. Okay, so for this we have given this array. Let me just copy this. It is -2 1 -3 4 -1 2 1 comma -5 comma 4. This is subarray that is given to us. That will be the continuous elements here. So it can't be like this, that we can return 1 and directly jump to 4, then directly jump to 2. No, this can't be the case. We have to take the continuous elements across the array. So if we decide to include both 1 and 4, we have to include this 3 also, -3 also in our sum. So then our sum will be 1 plus -3, that will be -2, plus 4, that will be 2 in that case. Okay, so what this algorithm states that whenever we encountered a minus, let's say a minus thing, let's say our current sum becomes minus. For example, here let's maintain a current sum. We will initialize it to 0 first, and we have to return a maximum possible sum that can occur. So let's just call our max answer. We will initialize it at the start to be integer dot min value, signifying that currently we haven't found any better answer than that. We will initialize it to minus infinity. Okay. So what we will do is, let's focus on this subarray 1 minus 3 4. If we try to calculate the current sum iteratively, at start when our I will be at here, what will be our current sum? Current sum will become 1, because current sum was 0, 0 plus 1 will become 1. Then now I will get increased to I is equal to 1, and our I will increase to here. Okay, then what will be our current sum? Then our current sum will become 1 plus minus 3, that will become equal to minus 2. Now think logically that our current sum is becoming minus 2. Now after this element I is equal to 1, there can only be two cases when our I becomes equal to here. There are only two possible cases here. What are those two possible cases? Either this value here is negative or a positive. Suppose if this value is positive, then our current sum will become minus 2 plus 4 is equal to 2. So we again goes to the positive direction of the side. But can't we do like, let's just ignore the current sum because it is already minus 2. So whatever we add in minus 2, it will always subtract from it. So can't we just ignore this case, these current sum, and initialize our new current sum is equal to 0? Then if we do our current sum minus 2 plus 4, current sum 0 plus 4, our answer will become 4. And as we have to return the maximum sum, so this is the better solution that we can get. It is kind of a greedy algorithm also on its own. So what we are saying is, in whatever step we found that our current sum is becoming negative, we are sure that if the next element after this negative is either positive or negative, we can reset our current sum to 0 and start from that next step. Because if after a current sum is equal to minus 2, if we start from here a fresh start when our current sum is equal to 0, we will surely get a better answer, a maximum sum, than if we include this minus also. Because this current sum is storing the previous side of thing, the left part of the element, left part of the 4, and it is saying that left part is giving me minus 2 as the sum. So why to include this minus in our sum if our sum will get reduced due to this minus sign? So we will completely ignore this minus 2 whenever we found out that our current sum is becoming minus 2, and we will freshly start a new sum which will be current sum is equal to 0 and start from there onwards. So our algorithm will look something like this. For I in nums, we will make a current pointer will be equal to current plus I. Then we will calculate our max answer, that this is the answer that we are going to return. It will be max of max answer comma current sum. But if our current is become less than 0, then we are sure that just skip the left part. skip the minus part and start with the fresh start. So we will update our current to 0 here, and initially we will start our current from 0 and our max from minus infinity. So this is how this algorithm will look like. I hope I have explained it in depth. Let me write the code and let me try to explain there also how this algorithm is working. So let's just do a line by line breakdown of the algorithm. This is for the iterative purposes. It will give our time complexity of order of n. We are traversing in our array using this. We are updating and calculating the current sum. What is the current sum till here? Let's suppose if we start from here to here, then our current will store the sum from here to here. It will store something like 1 plus minus 3 plus 4. It will store 2 in it. But for our code purposes, it will not run, because in the middle of it, because of this minus 3, when our current sum become 1 plus minus 3 minus 2, we will skip these two part and only include this in our current sum, because this will be the start in that case. Then I am storing this max because we have to return the max sum. So max sum will be stored in something like current sum and already max. If the current sum is greater than the max, we will update our max to the current sum, otherwise we will keep the maximum sum as it is. And this is the condition I have explained you, how the breaking point and how the current sum reset is occurring. That if our current sum become less than 0, we will start from the right side, we will ignore the left sub array sum because it is negative already. If we add negative in a positive, it will lessen our maximum sum there. So we have to start from a current sum is equal to 0. We will do a fresh start here. So this is all the lines of the code we will require to solve this question. As you can see, it is hardly a 5 line of a code, and it is considered a medium level question. So because for the brute force approach, it is quite easy. We can solve this question in order of n square, or we can sort the array and work around with the largest sum sub array or something like that. No, we can't sort this array, because in that case the relative order will change. So we can't sort, but we can write a brute force of order of n square where we can do a nested loop and calculate all the sub arrays possible and calculate their current sum again and again and compare what will be the maximum sum. So this is the algorithm that you require to optimize the brute force into the linear time complexity of n time complexity, Cadence algorithm. Without the knowledge of this Cadence algorithm, you can't convert this brute force into the optimized solution. So let's just quickly write the code for this. I have already written the code here. So our current sum will start from 0, then our answer will start from minus infinity first, then I will write a for loop for the traversal for int I in nums. I will calculate the current sum. Current sum will be current sum plus I. Then I will update our answer, that if we found a better solution than our max, we will update our answer to that current sum, otherwise we will keep the maximum as it is. Then I will write a if condition, that if our current sum in any step becomes less than 0, just start a new current sum which starts from 0, and we will recalculate the sum of the subarray, because there is no point in including a negative in our maximum subarray calculation. If it is becoming negative, it will only reduce our maximum sum, not increase our maximum sum. and at last we will return our answer. So every test case is passed, all the test cases are passing, and it is the best optimal solution out there. This question is very easy. I don't know why it is medium. It should be easy question. Let me just try to explain what the problem is asking. For this problem, we have given an array nums with n objects colored red, white or blue. Sort them in place so that the objects of the same color are adjacent with the colors in the order red, white and blue. Red is defined as 0, white is defined by 1 and blue is defined by 2. So you must write this problem without using any library sort function. So we just need to sort basically we have to just sort the nums array in this problem. It is asking just that, and while asking that it is also saying to use a in place sorting algorithm. So we can't use a different nums different array to store or have a space complexity of order of n. We can't have, we have to use only variables or a constant space complexity. We will write an algorithm of order of n time complexity here, a linear time complexity code here. This is very easy. We just need to sort the nums. Basically here if you see, all the zeros are at the start, then 1, then 2's. Okay. And as our nums will surely contain the numbers either 0, 1 or 2, we can make a pointers, we can make a counters to count how many 1's are there, how many 2's are there and how many zeros are there. So what we can do is we can do int count zeros, int count ones, int count twos. Now we will count them for int I in nums. If I is equal 0, then our count 0 pointer will increase. Else if I is equal 1, then our count 1 pointer will increase. Else it is guaranteed that the remaining element has to be 2 only, so our count 2 pointer will increase. Now we have all the countings of count 0, count 1 and count 2 in them. So for this question our count 0 will store 2 in it because there are 2 zeros, and our count 1 will also store 2 ones because there are 2 ones in this solution, and our count 2 will store again 2 because here the 2 is occurring 2 times also. Now we will make a pointer int I is equal to 0, and we will store the length of this nums.length in a variable n, and we will use this I to iterate over the nums, and we will update and sort side by side. So while our I is less than n, what we will do is okay, let's just use a for loop here. For int I is equal to 0 till I less than our count of 0, because at start our count zeros will be there. Let's say there are 2 count zeros, so this count 0 pointer will have 2, in it, so we have to put two zeros in the starting. We have to put two zeros in the start. So we will write a code like int I is equal to 0 to 2. We will write nums of I is equal to 0. This is very easy solution I am writing here. So I hope I don't have to explain it in more depth. Nums of I is equal to 0, because at start we have to put zeros only. So I am checking how many zeros are occurring. I will loop till that number, and I will just write nums of I is equal to 0. Now after 0 I have to put 1, so I will just write another for loop for int I is equal to 0 to I less than count of 1. This time I will do I plus plus, and I will do nums of I is equal to 1. But here I have to put this 1 after the 0, after the zeros. If I write this, then our nums of 0 will become 1, and our starting element that is at 0th index will become 1. So what I have to do is I have to update this one at the second index, 0 1 second index, or the third index if we are counting in a one based indexing. So how to get till here? I will just do this, that I will add count zeros length in our I. In that, by doing that, I will skip these two and I will directly jump to the third element at the start only. Now our 1 will also get updated into the right positions of the nums array. Now the only left element to put in our array is 2. So I will start another loop from int I is equal to 0 till I less than our counter of 2 this time. I plus plus. Then our nums of I plus counter of 1 will become 2. And I have to add the length of counter of zeros also. Basically what I will do is I will plus the length of this, then this, so that I get to the correct index, that is at here 0 1 2 3 4, fourth index, or basically the fifth element in the array. Because if I do 2 plus 2 here, the length of current of 0 is 2 and the count of 1 is also 2, so 2 plus 2 will be 4 and 4 plus 0 will be 4, and I will be at the correct 0th index position where I have to put the 2 in that index. Let's just submit this solution. I hope this is correct. So all the test cases passed, and this is the best optimal solution that you can make, because it is taking order of n time complexity and it is also doing the solution in order of one space complexity, because I am only using the 3 variables here. There is no extra order of n array that is adding in our calculation of space complexity. So this was very easy question. So let's just try to solve this question. So this question is asking to rotate an array. We will be given an integer array nums. We have to rotate the array to the right by k steps, where k is a non-negative number. Okay. So what we have to do is we have to do a kth type rotation. So let's just first normalize our k. Our k will be k percent n, if I'm not wrong, or n percent k. K percent. Basically this is the normalization of our k. Let's just define our n also, that our int n is equal to nums dot length. Let me just explain why I write the k is equal to k percent n, because okay, I am writing a example. Okay, so here see, this is the array, it is already sorted, and we have to rotate this array to the right for the 3 steps. So in order to rotate it to the right, in the first step our array will become something like this: 7 1 2 3 4 5 6. Basically this 1 will shift to the right, this 2 will shift to the right, then this 3 will shift to the right. Similarly this 7 will shift to the right. Basically there is no right towards this, so it will move towards the start here. So our array will become like this if we rotate for the first step. Now if we do a rotation for the second step, then this 7 will go here, then this 1 will go here, then this 2 will go here, and this 6 will move to the start. Similarly this will also happen. In this case 6 will move to the right, then 7, then this is how the 3 rotation is occurring to the right of an array. This is our input array, and we have to return this as our answer in the nums only. We have to update a nums only. So a brute force approach will be to use different arrays in order to store these numbers. What I mean by that is, let me just explain you. Okay, so firstly, why I write this line of code, that k is equal to k percent n. I wrote this, for example, let's say here our n is 4 and we have to do a rotation for 5 times. If we do a rotation of 5 times, okay, so let's say if we do a rotation of 4 times in this array, if we do a rotation for the 4 times, what will happen is our 1 will move to the right, then our 2 will move to the right, then our 3 will move to the right, and the 4 which was at the last will move to the start. This is our first rotation to the right. Then our second rotation to the right will be these steps, these elements will move to the right. So our 4 will move here, our 1 will move here, then our 2 will move to the right, and our 3 will move to the start. Okay. Then what will be the third rotation look like? Third rotation will look like something like this. This 3 will move to the right, then this 4 will move to the right, then 1 to the right, and this 2 will move to the start. And if we do the rotation for the 4th time, then our array will become same array which was given to us. So here what you can see is that if k is equal to n, because in this case our k was 4 and our n is also 4, then the effect of rotation is same as no rotation at all. No rotation at all. The effect of rotating 0th time is equal to rotation of nth time. Similarly, rotation of effect of 1 is equal to rotation of effect of n plus 1th time. So either we rotate it 1 time or we rotate it 5 times. It is same. And also rotation of 0 will also be equal to rotation of 2n times, because either we rotate it 0 times or we rotate it at 4 times or we rotate it at 8 times, the answer will remain same, the original array itself. So that's why I normalized it, so that we just need to look from 0 to n minus 1. And if our rotation is given to us as n, if the rotation of us is given to n, we will just do the rotation of zeroth. That's why n, that's why k is equal to k percent n handles this case. Now if in that case, if our k is n and our n is n, so n percent n will lead to 0 as an answer, and n plus 1 percent n will lead to 1 as an answer. So what I am ultimately saying is that either we do a rotation of n plus 1 or we do a rotation of 1. The effect of n plus 1 and k is equal to 1 is same. That's why I normalized it using this. Now what we can do is, let's say this is our array given to us. We have to do a rotation of k is equal to 2. So the first rotation will look something like this, that 1 will go here, then 2, then 3, then 4, then this 2, sorry, 4, 1, 2, 3. So we have to update our nums from this to this. This is our input and this is our output. So what we can do is, we can make a array 1 of length, let's say k. We will make a array of length k, basically length 2, and what we will do is, we will store our these two element in that array. And how we can store these two element? What we can do is, we can just run our for loop for I is equal to 0 to k, and we will do like arr 1 of I is equal to arr of I. So what I will do is, this is, let's say, our arr, then our arr of 1 will look something like 1 and 2 only. Okay, and what I can do is, I can also make a arr of 2 which will store the remaining elements, so arr2 will store the remaining elements 3 and 4. And at last what I will do is, I will just do arr of 2 plus arr of 1. Because arr of 2 will store the remaining elements 3 and 4 plus our arr of 1 was storing the starting indexes till k, these indexing, so 1 comma 2. And when we will do the concatenation of these two array, a combined array will be there, that will be 3, 4, 1 and 2, and this will be our answer. This is what they were asking from us, so we will just return this, or we will just update our nums, our original array, to this array. But for this there is one issue. We are using order of n space complexity, because we are using two different arrays, arr of 1 for storing the starting indexes and arr of 2 for storing the remaining indexes. So it will be a order of n space complexity. If the constraint is that we have to use the constant time complexity, or we can't use the space complexity of order of n, then we have to do something else. But for now, this is good. Let me just write the code also, so that you get a better idea of how we are writing the code. So I will make a array list of integer. Let's call this arr of 1. It will store the starting indexes till k is equal to 3. Let's just try run this example also using my approach. So here the k is equal to 3. So for the ARR of 1, we will write something like for I is equal to 0, 2, 2, 3. Then our ARR of 1 will store these elements. These 1, 2, 3 and 4, because 0, 1, 2, 3 will get added because of the 0th indexing thing. So we will write a loop from 0 to 3, then our 0, 1, 2 and 3 will be added to the ARR of 1. So our ARR of 1 will contain 1, 2, 3 and 4 in it. Okay. Then in our remaining array we will add the left out numbers in that, and we will just do ARR of 2 plus ARR of 1. Okay. So what I have to do is I have to store these 3 elements in ARR of 2. I have to store these 3 elements in ARR of 2. So how to get till this index? How we can get? Let me just write this example in here only. 1, 2, 3, 4, 5, 6, 7. And our k is given to us as 3. So after 3 rotation, our answer will become something like this: 5, 6, 7, 1, 2, 3, 4 and 5. Sorry, 1, 2, 3 and 4. So one key observation what you can make is these 3 elements are moving to the starting of the nums array, and this 3 is coming from this k, because k is given to 3. So these 3 will go to the left, because at the first step this 7 will go to the start, then this 6 will go to the start, then this 5 will go to the start. So in our ARR of 2, we need to store these 3 elements 5, 6 and 7, and we will store the remaining elements in ARR of 1. So at last we will do ARR of 2 plus ARR of 1. Now in order to store these 3 elements in ARR of 2, what we can do is we can run our for loop. We can run our for loop from n minus k till n. We can run our for loop from n minus k till n, because let's just calculate n. Here n is 0, 1, 2, 3, 4, 5, 6, 7. Here n is 7, and this index is at 4th index. And if we do n minus k, it will be 7 minus 3, which will be 4. So from 4 to our n, basically n minus 1, so till 4 to 7 we will run our for loop, and we will add this element to our ARR 2, then this element to the ARR of 2, then this element to the ARR of 2. After that we will make our ARR of 1, and in order to make our ARR of 1, what we will do is we will run our for loop from I is equal to 0 to n minus k minus 1. because it will be 0th index, so we will start from the 0th index and it is going till this third index, that is n minus k minus 1, n minus k minus 1, that will be 3. So this is how the pointers are defined here. I hope I have explained you how the ranges of the for loop and how we will define the starting of the I and the ending of the I in both of the cases. For the right part, we will start from n minus k till our n, because the last three elements are going to the starting. So we will add these three indexes at the start. So we will do n minus k till n, and we will add the remaining elements in our ARR of 1, and at last we will do ARR of 2 plus ARR of 1, and we will assign it to our nums array. Okay, so our for loop range will be for int I is equal to 0 till I less than n minus k minus 1. This is the ARR of 1. This is for the ARR of 1. So I am writing this part from here till here, n minus k minus 1, n minus k minus 1. I will add these all elements in our ARR of 1. Now our ARR of 1 will get filled. Now I have to fill the ARR of 2, and the ARR of 2 contains the last kth elements in it. The last kth elements in it, that will after the rotation will move to the start of the nums array. So to store these, our starting pointer will be n minus k, and we will move till n. So for int I is equal to n minus k minus 1, n minus k, that was the starting index, and we will move to n minus 1, so I less than n, I plus plus. We will do ARR of 2 dot add nums of I in it. Now our ARR of 1 and ARR of 2 is filled with the appropriate numbers we desired. So after these two for loops, our ARR of 2 will contain 5, 6 and 7, and ARR of 1 will contain all the remaining elements, that are 1, 2, 3 and 4. So at last we have to update our nums to this thing. So to update our nums, what we will do is we will iteratively took all the elements of our ARR of 2 and put them at the start, and then all the remaining elements to the end of the ARR of 2. So we will do something like ARR of 2 plus ARR of 1. So for int I is equal to 0 till I less than at first we have to put the ARR of 2's element, so let's just iterate in ARR of 2. And after ARR of 2's element, I have to put the ARR of 1's element after the ARR of 2's. So for int I is equal to 0 till our I less than ARR of 1 dot size. All the remaining elements are stored in ARR of 1. So I am extracting them one by one using this iterator. I will update our nums I to ARR of 1 dot get I, and we don't have to return anything because here I am just updating this nums only. And see, this I, as the starting elements are stored via this ARR of 2's element, so nums of 0 will be stored to this 5, then nums of 1 will store this 6, then nums of 2 will store this 7, but after that I have to store nums of 3 here to this 1. So in order to do and replicate that, what I will do is I will add the k here in order to normalize the starting of this thing. Now what will happen is we will do nums of 0 plus 3 and add 1 in that index. So nums of 3 will contain 1, then nums of I plus 1, that will be 1 plus 3, 4. Nums of 4 will contain the 2th element, and similarly onwards. So some issue is occurring. Okay, so I have found the issue. Here I have explained you that for the ARR of 1, our range will be from 0 to n minus k minus 1. This n minus k minus 1 was the inclusive range because we have to include the n minus k minus 1th element also, because n minus k minus 1th element will be this 4, and we have to include this 4 in our calculations because n minus k was this, and we have to include this n minus k minus 1 in this left side. So what I have to do is I have to write a range from n minus k minus 1 inclusively. So what I will do is I will write an equal to symbol here. Yep, so now our code is getting accepted. I know this is showing that our code is solving the problem very poorly, but let me explain you slightly here why this is showing like that. Let me just try to explain it here. Okay, so as you know, what I have done is I have run a for loop 4 times. I have run a for loop 4 times. So our time complexity is this order of 4n, which will be simply order of n time complexity. This is a linear time complexity. So we don't have to worry about this 4n because it is a constant. We can ignore this. So this is the optimal solution in terms of time complexity. In time complexity, it is optimal. We can't do a constant time complexity because what comes after this order of n? A log n or a constant time. How you can solve this algorithm in a log n time? For the log n time, the only algorithm that comes in my mind is binary search, and we can't apply binary search here because the array is not sorted at all. Array is not given a sorted array. If the array was sorted and we have to do some kind of a rotation, which I have already solved in the binary search questions, then we can work around and do something in that case. But here, as there is no mention of any sorted nums array, we can't solve this question in order of log n time complexity. So the best solution which we can get is order of n linear time complexity, and we are writing the algorithm in that time complexity only, because this 4n doesn't matter. We can drop this 4 as it is a constant here. Now let's talk about the space complexity. Many will say that you can do a better because I am using here two arrays here, so our space complexity is something like order of 2n because I am using a 2 array to solve this question. Okay, firstly this order of 2n means order of n only for the space complexity, right? In the worst part, our algorithm is order of n space complexity, and our time complexity is also order of n time complexity. I have explained you this is the optimal you can get, and for this order of n. So can we do a better? Can we write this algorithm in a order of one time complex, in order of one space complexity or something like that? So the answer to this question is no. We can't do order of one space complexity here. But why? Earlier I have shown you that I have written an algorithm that is like this. Let me show you. An algorithm that uses a reverse function to solve. Here you can see that I have not used any array, any extra array to solve the question. So you can say something like, see, we can do a better solution where order of one space complexity is there. You can clearly see that here no extra space or array is defined, so many will assume that here the space complexity is 1. But you are missing a key point here, that this is a recursive code. I am solving this code via recursion. This is also a order of n time complexity code only, because I am going from start till end and I am writing this while loop. So our time complexity here also is order of n only. So we can't do better than that in terms of time complexity, and in terms of space complexity also this is a recursion. And in recursion what internally happen is, in recursion what internally happen is, a recursion stack is formed, and that will be order of n space complexity internally. So you can say that we can't just see that there is a order of n space complexity of extra array just by looking the code, but internally in the stack, internally when we do recursion, a stack is maintained of space order of n here also. So here also the space complexity is order of n and time complexity is also order of n, which was already our question had. So there is no point in optimizing the algorithm anymore. So I hope I have explained you the internal concepts of this thing. Now the next question is this product of array except self. Let's just quickly do these two questions quickly. Let's just remove the code. So for this question we have given an array nums. We have to return an answer such that answer of I is equal to the product of all the elements of the nums except nums of I itself. Okay, and we have to write an algorithm of order of n time complexity without using any divisions operations. So let me just try to explain you what the code is asking and why the restrictive line is such an obscure line that you must write an algorithm that runs in order of n time complexity. That we get that they are expecting a linear time complexity code, but they are also saying that you can't use the division operation. Okay. So let me just try to explain why they are trying to say that and what they exactly try to mean by that, and what are the directions they are giving using this line. Okay, so let's just use this example only, 1 2 3 4. 1, 2, 3, and 4. So what they need is they need a resulted array of the same size. Here the size is 4, so our resulted array will also be the size of 4. So we will write like new int of 4, then our resulted array will initialize to this. What they need is, what they are asking is the product of, sorry, given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except that element itself. So here, as this is 1 here, so ignore this, I is equal to 0. So ignore this element at start and calculate all the product. 2 multiply 3, 6, 6 multiply 4, that will be 24. So at start our result will be 24 at for I is equal to 0. So we have ignored this I is equal to 0th element, that is 1. We have not included that in our product, and we just do the product of all the remaining elements. Right? Now for the second element, whenever I becomes 1, this is our current element. So our ANS of I, that is ANS of 1, this will get updated, and this will get updated to all the products of all the remaining elements except this 2 itself. So that will be 1 multiply this 3 multiply this 4. 3 multiply 4, 12, and then 12 multiply 1, 12 itself. So our ANS of 1 will be 12. Okay, you can see that we haven't calculated or multiplied this 2 in the calculation for this 12, because for I is equal to 1, this is the self number, and we have to ignore the self number, and we have to take all the other iterations, all the other indexes elements. Now our I will get increased to 2, and for this we will not include this 3 in the calculation of the product, but we will include all the remaining ones. All the remaining ones are these. So 1 multiply 2 will be 2, 2 multiply 4 will be 8. So this will be 8. Lastly, our I will again move to the last element, that is here. And for this we will ignore this element in the calculation of the product. So we will simply return 1 multiply 2 multiply 3 multiply just 3 till 3. 1 multiply 2 multiply 3 will be 6. So this is our resulted array or our answer that they are expecting us to return. Let's just quickly verify this. 24, 12, 8 and 6. 24, 12, 8 and 6. So yeah, this is the answer they are expecting from us. Okay, so if order of n time complexity was not given in the question, so what we can do is we can write an algorithm of order of n square. It is a brute force solution that you can write. It will be something like a nested for loop. So what we will do is we will fix this ith element, I is equal to 0. We will fix this and we will do the product of all the remaining elements and store our ANS of I as the product that we got. Then we will move our I to 1, and we will write an inner loop from j is equal to 0 to n, and we will calculate the product of all the remaining elements again using the inner nested loop, and we will update our ANS of I to that product. And similarly we will do this for I is equal to 2, for I is equal to 3. We will have to do an iteration from 0 to n again and again, and if I is equal to j, we will continue, because we don't have to take the same value itself, because whenever I becomes equal to j, we have to skip that into our product calculation. We don't include that number in our product calculation, as it is asked by the question that we have to return the product except self number. Okay, so that's why they are saying that you can't use order of n square time complexity, because that will be very easy. That will be a nested loop only, the nested for loop for I is equal to 0 to n, and then j is equal to 0 to n. If our j is equal I, we will skip, otherwise we will calculate the product, and at last we will make our ans of I is equal to the product, and we will start our product with 1 only. Okay, so this is the brute force solution. They are not asking for that. That's why I have written it in rough, and I have explained you the broader code of that, how you can make that. But now they are also saying you can't use a divide operand. You can't use a divide operand also. Sorry, this is percentage sign. So you can't use a divide operator also. You can't use the division. Why they are saying this? Can we write a code that is order of n, and also used via this operand, the division operand? Yes, we can write, and that is very trivial to solve. Let me just try to explain you that here quickly. 1 2 3 and 4. So what we can do is, we will run a for loop from I in our nums, and we will calculate the product. We will calculate the total product. What is the product of all the numbers? That will be something like product multiply I. So at last of this for loop, our product will store 1 multiply 2 multiply 3 multiply 4, 24. Basically the product of all the elements. Here I am not skipping any element till now. So we get our product, that is equal to 24. Now what we can use is, we can write another for loop below this for I is equal to 0 till our n. Okay, and what we will do is, we will write our result of I is equal to product divided by nums of I, and we will just simply return our result. Just this for loop to calculate the product, all the products, and then we will write an again for loop from I is equal to 0 to n, and we will update our result of I is equal to product, that is 24, divide by the current number, because we don't have to include that. Basically it is happening something like this. Let's say our 4 elements are A, B, C and D. Then our product will store A multiply B multiply C multiply D. This is our product calculation number. Then if you see the question requirement, what we have to do in result of 0 is that we have to return the product of all the elements except the element that is at the 0th position. So we have to do something like B multiply C multiply D. And in order to get this, what you can do is, you can do something like product divided by A. By doing that, this A will get cancelled out to this A, and our remaining answer will be this only. And when we do a result of 1th calculation, you can see at the result of 1th index there is B. So when you do product divided by nums of 1, that will be product divided by nums of 1, that is B. Again it will be something like A multiply B multiply C multiply D divided by B. This B will get cancelled out with this B, and we will get A multiply C multiply D. That is the required answer. That is, they are asking for this result of 1, that product of all the elements except the self. So this is very trivial. So that's why they trickyly excluded this division operand and this order of n square component. In an interview, if they forget to mention that you have to solve the question in order of n only, you can write this for loop. And if they say you have to write an algorithm of order of n only, So you can do something like this only using the maths. Basically it is a basic maths, to be fair. And after that, if they say, okay, you are quite finding the loopholes in the questions language, now give me a solution that is order of n plus not using a division operand. Now what you will do? Now what will you do? Now the main algorithm here comes. 1, 2, 3 and 4. Okay, so one key observation here is that now we can't use the division operand, and now we can't also use the nested for loop. But what we can do is we can take the benefits of the space complexity. What we will do is we will make a two different arrays of size n, because earlier when the both of the code I have explained you there, I have not used any extra space complexity. They were the order of one space complexity code. So if they ask that write the code of order of n time complexity, but the space complexity must be order of 1, then you can write this solution. But if they say write a code of order of n time complexity, but you can use the space complexity of order of n, then you can write this code that I will now explain you and try to set the intuition of that. So in that question, what you will do is you will make a array. You will make an array that will be calculate pre-product, basically prefix product, and you will make a different array also. Let me just do like this. This will be prefix product. This will calculate a prefix product, and it will also be the size of the same. This will be also of the size of 4 only, new int of 4 only. And what you will do is you will make a another array of same okay. You will make another array known as suffix product of same size, against size of 4 only. You will make these two product arrays and initialize it with 0, because if you don't do anything it will automatically be 0 only. And as the name suggests, you will store the prefix product here. You will store the prefix product here and the suffix product here. What I mean by the prefix product and suffix product is that, let's start our for loop from I is equal to 1 till n. Then let's say our array is something like this, and we are at here. What is the product before this one? What is the product before this? What will the pre-product of this 0th index? It will be 1 only, because there is no element at all. That means the product is 0 or 1 itself. If I write the product to be 0 itself, then 0 multiply any number will become 0. So that's why I will initialize it with 1 only. So initially our prefix product for 0th index, that is here, is 1. I will initialize that from here. Now I will increase our I to 1. Our I will go here, I is equal to 1. Now what is the prefix product for this 2? The prefix product means you have to see the left side. You have to see the left part, and you don't have to include this 2 in that. You can clearly see that is 1. So in for loop, how you can replicate this simulation is like, you will write something like prefix product of ith element is equal to prefix product of I minus 1 multiply by nums of I minus 1, because this prefix products will give 1 and this nums of I minus 1, nums of I minus will 1 will give this 1, and this will also give 1, and 1 multiply 1 will be 1, and we will get prefix product of 1 to be 1 again. Okay, now our I will move to one step ahead. Sorry. Now our I will move to I is equal to 2. Now when our I will move to I is equal to 2 again, now what is the pre-product of I is equal to 2? It will be 1 multiply 2, the left side of it. It will be 1 multiply 2, that means 2. It will be 2. It will be 2. And how you will get the using this for loop? That means prefix product of I is equal to 2 is prefix product of I minus 1, that is 1 multiply nums of I minus 1. What is nums of I minus 1? That is nums of I minus 1 is nums of 2 minus 1, that is nums of 1, that is this 2. So 2. Now this prefix product of 2 will become equal to 2. So prefix product of 2 is 2. Now our I will move ahead, one step ahead. And our I will move to I is equal to 3. And when our I becomes I is equal to 3, in that case, what is the prefix product? This is the prefix product, that is 1 multiply 2 multiply 3, that means it is 6. And how you will get that? It is pre-product of I minus 2. I minus 2 will be prefix product of 3 minus 1, that is 2. That is 2, which is 2 multiply nums of I minus 1. What is nums of I minus 1? Nums of 3 minus 1, that is 2. Nums of I minus 3, nums of 2 is 3 here. So it will be 2 multiply 3, that means 6. That's how we will initialize our prefix array, and we will get our prefix array something like this. We will get 1, 1, 2, 6 in our prefix product array. This will how you will get a prefix array. Okay, now what we will do is we will also calculate the suffix array. And in order to calculate the suffix array, what you have to do is, in order to calculate the suffix array, we will just run our for loop from n to 0, and we will calculate the suffix product. And what is the suffix product of this 1, 2, 3? Let's say 1, 2, 3, 4. Here, for here, our suffix product will be 1. For this, our suffix product will be 4. For here, our suffix product will be 3 multiply 4, that is 12. For this, our suffix product will be all the remaining elements that are here, that will be 24, because 2 multiply 3 multiply 4 will be 24. So our suffix will look something like this: 24, 12, 4 and 1. Now we have a prefix product and a suffix product. What we will do is we will make a resulted array, and we will do prefix of I multiply suffix of I. So prefix of I multiply suffix of I, prefix of I multiply suffix of I, prefix of I multiply suffix of I, prefix of I multiply suffix of I. 1 multiply 24 will be 24, 1 multiply 12 will be 12, 2 multiply 4 will be 8, and 6 multiply 1 will be 6. And this is our answer that we will return. 24, 12, 8 and 6. Let's see. 24, 12, 8 and 6. 24, 12, 8 and 6. So again, quickly giving you the summary, what we are doing is we will calculate a prefix product array. That means whatever the whatever the sum is to the left of that index. Let's say if we are calculating a prefix index product for this 2th index, we will calculate all the multiplication that are here, that is 1 multiplied 2, and store that in our prefix product array of that. Similarly, simultaneously what we will do is we will make a suffix product array, and the suffix will be the directly opposite of that. Earlier we were storing the left part, now we will store the right part. For this I is equal to 1, what is the suffix product of that? That will be all the elements that are on the right side of this, all the elements product that are on the right side of this, that is 12. Here that is 12, so we will store 12 for that suffix product array, and we will multiply prefix by suffix, and we will get our answer that we are trying to look for. So in order to give a blatant algorithm and blatant intuition so that you get a better understanding, what we are doing is, let's say this is any arbitrary number present in our array. Okay, what we have to do is, let's say this is A, this is B, this is C, and this is D, and this is E. For this we have to return a result of something like A multiply B multiply C multiply D. We have to return this. I hope you know that we have to return A multiply B multiply C multiply D. Because it is the product of all the elements except self. So we have to return this for this 12. So what we are doing is, we are calculating the prefix side of this, and we are calculating the suffix side of this, So what is the prefix side of this? This will be, prefix side will be A multiply B, and the suffix side is C multiply D, and at last what we are doing is, we are just multiplying prefix with the suffix. So prefix with the suffix with the multiplication will be something like A multiply B multiply C multiply D. That is our answer that we are trying to look for. I hope this is completely clear to you, how we are defining the prefix product array and how we are defining the suffix product array. Prefix is on the left side of that, and the suffix is on the right side of that. So here I have written the code for the prefix calculation, that how we are going to find the prefix. The prefix is simply prefix product I minus 1 multiply the nums of I minus 1, that is on the left side of that. Similarly, the suffix will be something like nums of I plus 1, the right side of that. Okay, so let's just quickly write the code for that. I have explained you whole the code and all the brute forces approaches in depth, so now I will write the solution for that. As I needed the length of the nums again and again, so let's just define the variable for that. In int n is equal to nums.length. Now I will define a prefix array. Then I will define a suffix array. And I will define our answer that we have to return finally. And I will return this ANS. For prefix, our calculation is such that I will initialize our prefix of 0 to be equal to 1. Then I will write a for loop for int I is equal to 1 till I less than n. I am starting this from I is equal to 1 because in this prefix calculation I needed I minus 1. So I minus 1 has to be 1 minus 1, that is 0, should be greater than or equal to 0. That's why I need to start this from the smallest index that do not result in a negative out of bound errors. So that's why I will start from this I is equal to 1, and I am defining this prefix of 0 to be equal to 1 at start only. Now I will just simply copy this, that the prefix of I is equal to nums of I minus 1 multiply prefix of I minus 1. So after this for loop, our prefix calculation will be done. Now I have to do a calculation for the suffix one. So let's do that. For the suffix one, our for loop will be run from the right to left. For the prefix, our iteration was moving like left to right. Now for the suffix calculation, as we needed the right product, so we will move from right to left, because we will do something like 6 multiply 2 first to calculate the suffix for this. So we will do like int I is equal to n minus 2 till I greater than equal to 0, I minus minus. For the prefix, as I have initialized it with 1, so for the suffix also, because if you think clearly, what will be the suffix of this? What will be the suffix product of this 6? When I am at the last index, it will be 1 only, because there is no element on the right side of this 6. So what is the product on the right side of this 6? It is 1 only, because when you do 1 multiply any number, it will remain that number itself. So it is an edge case basically, that what is the number just right to the last index element. There is no element, so we will initialize that with 1. It is similar to that how we were calculating the left index for the 0th index, because for that, let's say our I is equal to 0 here. What is the prefix product of I is equal to 0? There is no element on the left side to that, so we will just using the 1 only there. So here also we will use 1. So suffix of n minus 1, the last index suffix is automatically 1. Then I will write the same formula for the suffix now, that the suffix of I is equal to nums of I plus 1. This time I will write I plus 1 because we needed the right side of that. For the prefix, let's say if I was at here, I was at I is equal to 1, I needed the left part. So in order to get the left part, I did write nums of I minus 1 in order to move the left. But to get the suffix, for the suffix, let's say I am at here I is equal to 1. To get the suffix, I needed the I plus 1th element. So I will write I plus 1th element here. Similarly for the suffix, I will write I plus 1th element, because we are filling this suffix array from right to left. That's why. And at last I will just do multiplication of this suffix and prefix and return our answer. That ans of I will be prefix of I multiply suffix of I, left side multiply right side, and we are not including the self, as I have explained you here. Left side multiply right side, and we are not including the middle element in that calculation. Now if you see clearly here, the time complexity is order of n only, because I am looping from I is equal to 0 to n 3 times, so it will be order of 3n. That will ultimately remove the constant part, so it will be order of n only. So for the time complexity part, it is order of n, that the question was expecting. And for the space complexity part, it is order of n, because I have defined extra space complexity here. extra 2 space complexity here, so the space complexity is order of 2n, that will be order of n only. Now the last question is remaining, that we have to find a duplicate number. So for this question we have given an integers array of nums containing n plus 1 integers, where each integer is in the range of 1 till n, but the one number here is repeating twice. Okay, so what we have to do is we have to return that number that is repeating. So for example, in this nums array you can clearly see that this 2 is repeating twice, so we have to return this 2. But here this 3 is repeating twice, so we have to return 3. And here all of the 3's are repeating again and again, so we have to return this 3. There is only one repeated number that is there in nums, and given an array of integer nums containing n plus 1 integers, where each number is in the range of 1, n. Okay, so this is quite a tricky question, but if you know the algorithm and what you are doing is, then it is quite a fun exercise to solve. If I'm not wrong, the name of the sorting which we will do here is cycle sort. I know it is an informal name that is given to this technique, but let me just try to explain you what it means and what exactly is that. I am just copying the first solution. So here the tricky part is we can't use a extra space complexity, so we can't use a frequency array to store the number of occurrences of each numbers. Basically what I'm saying is, let's say if this was not given to us, that using constant extra space complexity, this is not given to us, that we can use order of n space complexity. So what we can do is we can write a new array for the frequency maintaining, and we will maintain that to have the count of each element occurrences. Say if 1 is occurring one time, then the frequency of 1 will be 1. Here 3 is occurring one time, so the frequency of 1 will be 1. And here the 4 is occurring one time, so the frequency of 4 will be 1. But here the frequency of 2 will be 2 because they are occurring 2 times. And what we can do is, after this for loop, we will get our frequency mapping, and we will run again a second for loop to get our frequency. Wherever the frequency is greater than 1, we will return that index. So this is how a brute force will look like, but we can't use that because they are saying that you have to use only constant extra space complexity. So if interview do not specify that you have to use a constant space complexity, you can start with the brute force. It is quite trivial. I have explained you the gist of that. Now for this, we can't use an extra mapping for frequency checking, but we have to take the benefit of this range, that each integer here has to be in the range of 1, n inclusive, and only one element is repeating twice. Okay, so if suppose this thing was not given, that 1, n is in inclusive range, that all the elements that are there in this nums array, they are in this inclusive range, then it is very hard to solve that question. Then we can't solve that question using only extra space complexity. Then we have to use a frequency array in order to store the frequency, and we have to write the brute force approach. Okay, so let me just try to explain the cycle sort algorithm. Okay, so this is our nums array, and you can clearly see that these two are repeating twice, so at last we have to return an integer, that is this 2. Now what is the size of this? The size of this is 5. What we will do is we will try to put them in their correct position. Let's suppose there is 1. So what is the correct position for the 1? The correct position for the 1 will be at the starting. What will be the correct position for the third? The correct position for the third will be here at the third index. What will be the correct position for the fourth? It will be at here. What will be the correct position for the second? It will be here. Now, if we try to put this 2 in its correct position, if we try to put this 2 in its correct position, it will say that it is here, but here it is already 2. So there are 2 2's occurring. I am saying that we will write this if condition, that if nums of 2 is equal to 2, basically something like that, then we will return this 2. Why? Because we are trying to put this 2 in its correct position, that is at the second index, but there is already a 2 there which is at the correct position, so this ambiguity or this contradiction can only occur when there are 2 2's there in the nums array, because they are saying that there is only one element that is repeated. If 1 was repeated, then 2 1 will say that our correct position is this, and this will be a contradiction. Because there is only one element that is repeating twice or more than 2, that means all the elements that are 1 2 3 4 and 2, all the elements that are occurring only one time, this will move to their correct position simply, because 1 will move to the correct position, then 3 will move to the correct position, then 4 will move to the correct position. But when this 2 and 2 will come, this 2 will move to the correct position. But what will happen with this 2 is that it will automatically remain at the last position, because it will say I have to go to this 2, I have to move to this 2, but it is already there, the 2 is already at the correct position there, so we can't just remove this 2. So this 2 will remain at the last index, so what we have to do is we will return the last index. Okay, so let me just quickly try to explain you it one more time using the second example. 3 1 3 4 and 2. Here, what is the length of this nums array? It is 5 only. Okay, and what we have to return? We have to return 3, because this 3 is occurring 2 times, so we have to return this 3. Now let's make this nums. Okay, and now let's just try to put each of the element of this original nums, OG nums, into their correct position. We will move from 0 to n minus 1. Firstly, when we are at here, it is saying that nums of I is 3, which is not at the correct position, because the correct position of here has to be 1. So we will put this 3 into its correct position, that is here. This is 0th index, this is 1 index, this is 2 index, this is 3, and this is 4th index. Okay, let's just ignore these. Okay, so we have put this 3 into its correct position. Okay, because this 3 was not at the correct position at the I is equal to 0, because here the correct number has to be 1. Now see, we have put it this 3 in the correct position, but what was at index 2 earlier? Earlier at index 2, there was this 3. Okay, and it is at the correct position here. now the two elements are pointing to the same position and saying that this is the correct position for me to be there. So we can just simply return this 3 also to as our answer. Okay. So this example was not appropriate example that I was looking for. Let's say this is 1 only. Let's suppose this is our array. Now say this 3 is at the correct position. Okay, no problem. But earlier at this second index, what was there in the original array? What was at the second index? Earlier there was nums of 1. Now we have to put this nums of 1 into the correct position. So we will swap these two. We will swap 3 with the 1. So now 1 will go here and 3 will go here. Okay. Now we will do I++ and see that our 1 is already at the correct position. Here two numbers are pointing into the 1 position again, and we will return 1 in this case. Actually we will not return 1, but what will happen ultimately is all the elements will move to the correct position of there, but only one element will remain at the last, which will say that I have to go to my correct place, but at my correct place there is already a number present, so I can't go there. So we will just simply return the last index of the array, the last number of the index array. So in order to like give you a broader explanation, what happening here is that after our cycle sort, what will happen is all the elements will move to their correct position. This 1 will move to the correct position, this 2 will move to the correct position, this 3 will move to the correct position, and at the fourth index this 4 has to be there, so the swapping of these two will occur. So 4 will be here, 3 will be here. At last here also you can clearly see that the only last element remaining here is our answer, that is repeating twice, because all the elements here are at the correct position except this. Whichever element is repeating twice will automatically move to the last of this, because of this property that all the elements in the array is either from 1 to our n+1 inclusive range. Let me just solve with another example again. So here also it is n+1th range. So if these twos were not repeating, then what was the correct position of all the elements? 1 will move to the start, then 2, then 3, then 4. Then there has to be a 5 at the last index, but there was not 5, but one element was repeating twice. So at the last index, the repeated element will move automatically when we do cycle sort. We will move this 1 to its correct position, we will move this 2 to its correct position, we will move this 3 to its correct position, we will move this 4 to its correct position. Now we have to move this 2 to its correct position, but already in this place there is one element already present, so we can't move two 2's into one place. So this 2 place has to move to the last index, because that is the only space left. So we will just simply return n-1th number. I hope this is completely clear to you. Let me just quickly write the code for this. Int n is equal to nums.length. Our counter will start from int I is equal to 0. We will run our while loop from 0 to n. So while I is less than n. And at last I have explained you, we will return the last element because automatically the repeated element is the only element that is not at the correct position. That means has to be at the last position. So we will just simply return nums of n minus 1. Because of this property here, that there are n plus 1 integers, but the inclusive range has to be 1 comma n only, because between this 1 and n there is one element that is occurring twice, that is stopping the occurrence of this n plus 1th index to be there in the part of this. I hope I am making sense to you, because the cycle sort is quite a complex topic, but if you get an intuition that we are just moving the element into their appropriate positions, say say red has to be seated on the red seat, and blue has to be seated on the blue seat, and green has to be seated on the green seat. There are only 3 chairs. Then let's say there are n plus 1th colors, there are 2 reds. Then blue will sit on the blue chair, and red will sit on the red chair, and green will sit on the green chair. The remaining red will be unable to sit into its right position. So that will be our last n plus 1th position. That will be at the n plus 1th position, because there are n plus 1th integers. So that red color will be the left out color, which will remain standing at the last index. So we will return that. Now in this while loop, what we have to do is we have to put all the nums into their correct position. And how we will do that? We will do like something like that. If nums of I is not equal to I plus 1, because of the 0th index issue, that our nums of 0 is not equal to 1, because nums of 0 has to be 1. If nums of 0 is not equal to 1 and it is something else, let's say 2, then we have to put this 2 into its correct position. And what is the correct position of this 2? The correct position of this 2 will be this I plus 1th index. So we will write something like n nums of I minus 1. Let me just write here, nums of I minus 1 is equal to nums of I. And as we are doing a swapping, so we have to maintain a temporary variable also. And we will just do the swapping. And at last I will do I plus plus. I will explain this one more time. So our code is getting accepted. All the test cases should pass. Okay, so there is one error occurring here. We are outputting 1 nums 4 3. At the 0th index we have to put 1. So at the 0th index we have to put 1, and we have to check something like that, is we are at the correct position, that if nums of I is equal to I plus 1, that means nums of 0 is equal to 1 or not. Okay. If nums of I is equal I plus 1, then we don't have to do anything, we will just do I plus plus and we will continue. That means we are already at the correct position, we don't have to do anything. Okay, so let's just try to write this in else condition. Else okay, and here in the internal else we will check that if we get our repeated character internally only, we will return that element. That if nums of I is equal nums of I minus 1, basically this t, then we will return nums of I. So in every swapping, if the two swaps are exactly the same, that means the number which we are swapping, let's say we are swapping 2 and 2, if they both are same, we will return the repeated characters. Maybe this is correct now. Yep, so all the test cases passed and our solution is getting accepted. So let me just quickly try to explain you what I did and how I correctly corrected my code and what is this cycle sort all about. So nothing it is nothing but correctly putting the element into their correct position. That's all. See, for this, let's say this is our array that is given to us, that is 2 2 1 2 3 3 4. Okay, 1 2 3 3 4. Then what we are doing is we are starting from I is equal to 0 till our n to less than n, and we are checking that it is this one correctly at its correct position or not. See, we are doing like if nums of I, basically nums of 0 in this case, is equal I plus 1. This addition of 1 is happening here because of the 1 based indexing, because here nums of 0, that is this element, has to be equal to 0 plus 1, that is equal to 1, then only it is at the correct position. Here it is at the correct position, so this if condition will run and we will move to the next index, we will do I plus plus. Okay, then our I will move to here also our nums of I, that is nums of 1 is equal 1 plus 1, that is 2. This 2 is equal to 2, so again we will do I plus plus, then our I will move to here. Okay, here when our I is equal to 2, when our I is equal to 2, then nums of 2 is equal to 3, then nums of 2 is equal to 3, and 3 is equal 2 plus 1, that is 3. Again this if condition is satisfied, so we will do I plus plus. So we will do I plus plus, and we will move our I from 2 to this. I is equal to 3. Now this is the critical part. Let's say if nums of I is equal I plus 1, let's check nums of I, nums of 3 is equal to 3. Here you can see that nums of 3 is equal to 3, that nums of 3 is equal to 3. Is 3 equal I plus 1, 3 plus 1? No, this is not the case. So this if condition will not run. And if this condition will not run, then in our else case we are checking that now we are sure that we have to do a swapping. Because something is not at its correct position, so we have to do a swap. But before doing the swap, see, this is our else case. Here we are sure that something is not at the correct position, because if it was at the correct position, we are doing nothing, we are just moving to the next step. Now we are sure that nums of I is not at its correct position. We are sure. If nums of I is not at the correct position, then there are only two possible cases that can occur with it. Two possible cases are, it is repeated character, and the other cases, it is not repeated character, so we just have to move it to its correct position. See, for this else to be run, we are sure that nums of I is not at the correct position. As I have already explained you, that nums of I is coming out to be not equal to I plus 1. So this 3 is not at the correct position, because this is the correct position for the fourth element. So this is not at the correct position. Then there are only two possible cases that can occur, that either this 3 is a repeated character or it is not at its correct position till now. See the code of how we are doing a swapping. That means how we are pointing it to its correct position. We are making a temporary variable. And we are swapping this element to its correct position. But suppose if we do that swapping, let's suppose if we do that swapping with 3 and 3 here, what is the correct position of this 3? The correct position of this 3 is here. So what ultimately I am saying it, that nums of I is currently 3, and the correct position of this is nums of I minus 1. This is the correct position of this 3, and here in this position there is already a 3 present. So ultimately what we are doing is we are just swapping these 3's again and again. We don't need that. We will only swap them when they are different. Let's say here it is 4 and here it is 3. Then we are for sure know that this 3 is not at the correct position. So in order to make it into its correct position, we will swap these two. Then this 3 will move to the correct position and this 4 will move to the correct position. For the swapping, when there are two different elements, then only the swap will work. If they both are same, we have gotten our answer that these two are the repeated characters, so we will return 3. That's why in the code I am writing like this, that if nums of I is equal to this thing. That means the replacing character, the element which we are trying to put into the correct position, to the correct position there is already the same element present. That means it is the repeated one and we will return our answer. But if that is not the case, we will simply swap and put that nums of I into its correct position. I hope now it is completely clear to you how we are solving this question. Now all the miscellaneous questions are done. All the medium and hard and easies for this section is done. So we have done till now 41 questions out of 100, and this part is already done. So for the next I will try to do backtracking and the graph section. These three questions I will try to quickly solve them, or I will do the hashing ones, and we will reach the half 50 problems soon.